This is LAN WAN. This is Tuesday. We finished up PPP, we reviewed PPP, and we took the assessment for PPP. This is actually what we got going on. We did a bunch of things for frame relay, and they're working on the lab. And then we'll review frame relay topics on Thursday, and then work on the labs, and then finish out the day Thursday taking the frame relay assessment. This was the PPP review. We talked about PPP, link control protocol, network control protocol, and then we talked about a number of things. I didn't write them all down for that link control protocol. Talked a little bit about the physical layer, that idea of going from your DTE to your DCE. We reviewed those briefly. We talked about time division multiplexing and statistical multiplexing. Talked a little bit about the PPP frame, flag at the beginning, frame check sequence. We reviewed just briefly this little thing here. We talked about parallel communications and serial communications. And then we took the assessment on PPP. Then we switched over to frame relay. First thing we did, we talked about you could have a provider, and we want to get from this network at headquarters to this network at remote. And the first thing we talked about would be a lease line and run PPP between them. Then as a comparison, we talked about using a VPN and going through the internet. And though not all the choices, we did talk about the idea of just using the phone system to connect through. Public switch and telephone network. So these, especially these two here, led to the rhyme or reason of why we use frame relay. This could be too expensive for the bandwidth we want, and if we have bursty traffic that doesn't use a lot of bandwidth all the time, we could use the internet, but we have no control over how much bandwidth, or there can be some security issues there, but you don't have as much control than if a provider tells you they're going to provide a certain amount of bandwidth for you to go through. Okay? Then we talked a little bit about, again, is that circuit switch or packet switched? Well, it ends up being packet switched. That's how we can share bandwidth of lots of other people inside that frame relay cloud and get the most for our money. So then we went through how does some terminology in terms of how that might work. Committed information rate, you can get a committed information rate, and then you can get a burst rate. Maximum number of bits that the switch agrees to transfer during any committed rate and measurement interval. And then an excess burst on committed bits that the frame relay will attempt to transfer beyond the CIR. We talked a little bit about that discard eligible bit. And then we talked about congestion. Explicit congestion notification. The switches can mark a forward explicit congestion notification bit, and they can mark a backward explicit notification bit. And you can look those up in the curriculum, but they can let a device know that what's coming was congested, and then the router can decide if it's going to do anything with it, or a router can know that it's the source of the congestion, and it can start sending less information through the cloud. Within the cloud, the frame relay switches manage that. So, we can set up our local loop, get our bandwidth. Here, for example, I said maybe a T1, and then you pay for your local loop, and then you'll pay for your permanent virtual circuits. What identifies that circuit will be your DELC, your data link connection identifier. And that has local significance. So that DELC has local significance. So that switch is going to get it across a particular circuit, and then, for example, here, paying for 256K, and we have that connection to the cloud. So in the cloud, we can have multiple permanent virtual circuits connecting them. So here's an example. DELCs are local, they identify the circuit. And the provider takes care of how it gets the information through the cloud, through a packet switched network, which then allows lots of people to use the cloud to keep the cost of the bandwidth down. Then students set up the lab, they're working in the lab, and then they're going to make sure these connections are there. When they leave, they plug them back into the respective connections to make sure they can access it remotely and work a little bit on the lab remotely before Thursday. And then here's the information to get in. The local IP for work server 2 is there at the top. The public IP for work server 2 is listed here, 207.165.226.182. Last name, first initial. There's one variation, Vincent Trent. We use his first initial and middle initial. And then this is the current password to get into your account, and then the student should change that. So that's a brief overview of what we did today. And the students will take the pre-assessment for frame relay before they leave.